My name is Megan Williams and I'm from the Geological Survey of South Australia. Today I'm going to give you a rundown of the stratigraphy of the Hiltaba Suite in the Gawler Craton, South Australia. Many of you will have seen a map like this before. It includes all of the igneous rocks in the Hiltaba Event, which occurred between 1595 and 1585 million years ago. But what links all of these rocks together? How are they similar and how are they different? In this talk, I'm going to focus on the intrusive rocks, the Hiltaba Suite, and show you some of the key characteristics that link these rocks together and distinguish them from other phases of magmatism in the Gawler Craton. Thinking about the Hiltaba Suite as a whole, it's dominated by granites, which are typically red to pink in colour. They're K-feldspar rich, even those which are unaltered, with lesser plagioclase and moderate amounts of quartz. Some plutons have smoky quartz, which indicates radiation damage. The granites are generally poor in micas and other mafic minerals. Typically biotite is the primary mica and often is altered to chlorite. Minor hornblende and magnetite also occur. Secondary fluorite is very common from the breakdown of biotite. The granites are generally massive, with foliations restricted to shear zones. Sericite, chlorite and hematite alteration are very common. Typically, these rocks are classified as A-type granites, although this is a bit contentious given the amount of alteration that's occurred in these rocks. Some of the examples have also been classified as I-types. There are a small amount and volume of mafic rocks in the Hiltaba Suite, which occur as both plutons and dikes. Intermediate compositions are quite rare, and the only known occurrences result from magma mingling. Because of the importance of the Hiltaba Suite for economic mineralisation and research interest, many informal names for the plutons have been used. On this map, you can see in the black boxes those units which have been formally defined, some of which require some redefinition, and in the yellow boxes those for which informal names exist. Without being formalised and put into a hierarchy, it can be difficult to find and link information about the intrusions. I'm currently defining these informal units and cleaning up the stratigraphy. Most of the granites will eventually be defined at the equivalent level to a sedimentary formation or of a member, and then they'll be grouped into subsuites. The general view of granites, including the Hiltaba Suite, is that they're typically homogeneous. Some examples like this occur in the Hiltaba Suite, including the Gawler granite, which you can see here. This granite is coarse-grained and very homogeneous, and it has this typical Mesoproterozoic red colour, which is common in the Gawler Craton of South Australia. This red colour is caused by pervasive alteration of the granite and is commonly associated with areas of known mineralisation, although that is not always the case. The Gawler granite is an example of pervasively altered granite that has no known mineralisation. The majority of the plutons in the Hiltaba Suite can have much more variable textures. This example is from the Charleston granite, which has a relatively well-defined extent on aeromagnetic imagery. The image in the top centre of your screen is the typical Charleston granite. It's megacrystic, K-feldspar dominant, and has minor yellow plagioclase and smoky quartz. But all of the other images on this screen are also from the Charleston granite. And so you can see there's quite a variation in textures here, all from one pluton. This is very typical in the Hiltaba Suite, and typically we don't have enough information about the spatial distribution of these textures to make any meaningful subdivisions. Many of the plutons in the Hiltaba Suite have textures characteristic of high-level intrusions, which are sometimes referred to as subvolcanic. An example here comes from the Buckleboo pluton, which has rounded feldspar and quartz phenocrysts in a fine-grained feldspar-rich matrix. Another example is from the Hiltaba granite, which is more equigranular but buggy. The high-level intrusive textures are particularly common in the granites on the margin of the Gawler Range volcanics, the intrusive component of the magmatic event. These units are classified as part of the Hiltaba Suite because the shallow intrusive textures occur within plutons which also have coarser-grained examples. Tonalites are very rare in the Hiltaba Suite and generally exist as small proportions. The best exposure is at Point Riley on the York Peninsula. These plagioclase rich rocks are very different to the K-feldspar rich rocks which dominate the Hiltaba Suite. The tonalite at Point Riley intrudes a K-feldspar rich granite and is then intruded by another K-feldspar rich granite, which are all of Hiltaba Suite age. There's another known occurrence of tonalites in the Tarcoola region in the northern Gawler Craton. Intermediate lithologies are also rare in the Hiltaba Suite, with the only known examples formed through mingling of mafic and felsic magmas. The intermediate lithologies commonly have more mafic-rich enclaves and granodiorite to diorite type compositions. In some examples, mafic rocks can be seen to intrude comagmatic granites, with the intermediate lithologies forming along the contacts. Mafic rocks occur throughout the Gawler Craton as small sub-round plutons, which are typically less than 5 kilometres across, and as dikes and sheets. A few larger plutons occur in the Mount Woods domain, the Olympic domain, and the York Peninsula. Very few outcrop and are mostly known from drilling or inferred from geophysics. The only defined Hiltaba Suite mafic pluton is the Curramulka gabbronorite, which occurs on the York Peninsula. This lithology is typically dominated by clinopyroxene and plagioclase, with some zones trending towards norite, which is dominated by orthopyroxene. A moderately large mafic pluton also occurs in the Mount Woods domain, which is informally known as the White Hill Gabbro. This pluton is dominated by gabbroic lithologies with lesser norite and minor ultramafics. The occurrence of ultramafics is very rare in the Hiltaba Suite, and in this case is thought to be formed by cumulate layering within a large mafic pluton. Fine-grained, generally aphanitic mafic dikes also occur, although they're generally not mapped on solid geology maps because they're very localised. The only named mafic dike is the Lady Jane diorite, which occurs in the Perseverance pit at Tarcoola. It includes fine-grained cyanodiorite with K-feldspar rather than the more typical plagioclase. Other mafic dikes occur nearby, which have a more typical fine-grained plagioclase diorite composition. I hope that's given you an idea of what's included in the Hiltaba Suite. The purpose of cleaning up the stratigraphy is to make information about the Hiltaba Suite accessible within the public domain, easy to find, easy to understand, and systematically described and defined. We know that there's a link between stratigraphy and mineralisation potential in other suites and terrains, so by tidying up the formal stratigraphy, we aim to assist explorers and researchers better target their efforts. If you're interested in learning more about stratigraphy, you can take a look at the Australian Stratigraphic Units Database, ASUD, which is managed by Geoscience Australia.